Hey everybody, we are in lesson 8.1, so brand new unit. This unit's on similarity, and basically you are going to be looking at two objects that appear to be the same figure. One is going to be larger or smaller than the other. So for that to happen, you have to have what's called a dilation. And you guys that have gone to the eye doctors and they put those little drops in your eyes and it dilates your eyes, then yeah, you know what a dilation is. Your pupils get larger so they can see to the back of your eye. All right, so we're talking about triangles. I mean, talk about anything really. Triangles, squares, rectangles, trapezoids. Probably mostly triangles though. All right, so we're going to talk about non-rigid motion, and that's basically an increase in size or something like that of a figure. Remember, rigid motions are translations because it's the same figure just shifted. Reflections because it's the same figure just flipped over. And rotations because it's the same figure just turned. Well, a non-rigid motion means you're changing the size of the figure, so you're giving it some sort of dilation, whether it's an enlargement or a reduction. Okay, in order for that to happen, you got to have a center of dilation. You have a scale factor, which means, okay, well, how much have I increased the size or decreased the size? And like I said a minute ago, enlargement or reduction. All right, so let's just get into it. I'm on page 461 of your consumable workbook. I've gone through all of these already. So let's just get to example number 1. All right, determine whether the dilation from triangle ABC to triangle DEF is an enlargement or is it a reduction? Well, it's definitely getting smaller, so it is a reduction. So triangle DEF is smaller than triangle ABC, so the dilation is a reduction. The scale factor is equal to the side length of DEF divided by the corresponding side length of ABC. Remember, corresponding means in the same position as. So if we're looking at 6, then the one that's in the same position as is the 2. All right, so we got 2 divided by 6, and that's going to simplify to a 1/3. You always want to simplify to get your scale. Oops, my bad. There we go. All right, so looks like we're done with example number 1. So I'm going to turn the page and do my check. I'm on page 462 of your workbook. All right, and they say we got a dilation from this WXYZ to this JKLM, and to me it looks like a trapezoid. They want to know if it's an enlargement or a reduction, and this is most definitely a reduction because from the original, by the way, we call that the pre-image, to the new figure, again, we call that the image. This is a reduction in size, so it's a reduction because it's getting smaller. And then scale factor, going from, let's see, 7 to 4. Usually what they say first, you put on top. Okay, and what they say bottom, what they say second, they put on bottom. Give me a second here for a second. All right, you guys. So, looking at this, typically it's whatever they say first goes on top, whatever they say second goes on the bottom. This is a reduction, so it's going to have to be number-wise a number, smaller than 1. So it'd be 4/7. All right. So scale factor dilation can be represented as a fraction or a decimal or a percent. For example, a scale factor 2/5 can also be written as 0.4 or as 40%. You guys that are eventually going to, well, I can even say that sales bridge math is going away in Tennessee to be replaced by sales statistics. So I can't even say that that you're going to see this again in sales because that's going away. All right, example number 2. Says Jalal, maybe, is printing a banner for his school's wheelchair tennis team based on the design shown. By what percent should he enlarge his design so that the dimensions of the banner are 5 times that of the original design? And what will be the dimensions of the banner? Okay. So dude wants to create an enlargement of the banner sign using a commercial printer. The scale factor enlargement is 5 because he's increasing it to 5 times the size. So your scale factor is going to be a K, which is 5. All right, so 5 times 100 is 500%. All right, so if the width is, I guess height maybe, or length and width, I don't know. Height is 6. 6 times 500. What's that? 6 times 5 is 30, so 3,000. And then 14 times 500. So that's going to be, do some math here, 14. 7,000. All right, so going to be a 30 inches by 70 inches. Okay. Oh, that was it. That's all I got to do. All right, well, there you go. Example number 2. All right, they got a check coming up. So, see, Natalia wants to print an enlarged family portrait of her mom. By what percent should she enlarge the portrait so the dimensions of its images are 2.5 times that of the original size? And what are the dimensions of the enlargement portrait? All right, so 2.5 is your enlargement. It's a big number bigger than 1. So you're going to basically take 18 times 2.5 and then 24 times 2.5. So that's 250 times as much, which means A and B are now gone. So it's either going to be C or D, just process of elimination. All right, so we're going to do 18 times 2.5, and that gives us 45. And then 24 times 2.5, and that's going to be 16. Looks like the answer is D. All right. So it looks like I'm done with the check on page 462. Let's move on to page 463 in your workbook. All right, so here it looks like they are giving you an idea of what a dilation looks like. So they're increasing triangle PQR to QR primes, and it looks like they even give you the dimension of the scale factors of 3. And here's how you would tell. You got to look at corresponding sides, and vertical lines and horizontal lines are the easiest ones to look at. So from Q to R is a block of 1. From Q prime to R prime is a block of 3. 3 divided by 1, because it's getting bigger, is 3. So the scale factor is a 3. And they're going to call that K, by the way. Okay, so let's look at example number 3, how to dilate a figure. All right, so we got triangle TRS with vertices, yada, yada, yada. All right, find the coordinates of the vertices of TRS primes after a dilation of a scale factor of 1/2. Okay, so it looks like to me that we're going to multiply everything times 1/2, because scale factor really is just a multiplication. So we're going to take -4 and -5, multiply by 1/2, and they do that for us. Then we're going to take 0, 6, and multiply by 1/2. So 1/2 times 0 is 0, and 1/2 times 6 is a 3. We got 0, 3 from our R prime. Same thing for S, 4, 3. So 1/2 times 4 is 2, and 1/2 times 3 is 3/2. Or you can put 1.5 if you're happy with a decimal. All right, so just multiplying here on your scale factor. So it's like we're done with example number 3. Okay, the check. We got triangle XYZ is vertices, yada, yada, yada. Find the coordinates of the vertices of the primes after the dilation of a scale factor of 4. Basically, we're multiplying everything by 4, everybody. So 3 times 4 is 12. -4 times 4 is -16. Again, just multiplying by 4. 6 times 4 is 24. 5 times 4 is 20. 8 times 4 is 32. And -2 times 4 is -8. All right, so multiplying, we're done with the check. All right, example number 4. Turn the page on your workbook to page 464. Okay, so we need to look at what's going on here. We got an image This is triangle ABC primes. After a dilation, scale factor, so got to find the scale factor. All right, so this is your original figure. Again, we call that the pre-image. It's the one that does not have the primes. So this triangle ABC is your original pre-image. The one that has the primes, A prime, B prime, C prime, is your image. It has definitely been enlarged. So we got to figure out what the enlargement is. Okay, so step one is we need to find the corresponding ordered pairs, looks like. So A is the ordered pair. Here's my origin. So negative 1, 2, 3, 4, 5, 6, 7, 8, 9. So negative 9, 0, because you're not going up or down any amount of movement. Oh, shoot. They wanted regular A. My apologies. My bad. Left 3. All right, B, over 0 up 2. And here they want the prime, so it's going to be negative 9, 0. And then B prime is over 0 up 1, 2, 3, 4, 5, 6, 0, 6. All right, now we got to do the distance formulas. Yes, and because we are not looking at horizontal lines or vertical lines, we can't just simply count this. So your choices are distance formula, which is what this is choosing to do, or you can do Pythagorean theorem. A squared plus B squared would equal C squared. So 3 squared plus 2 squared equals C squared. You can do the Pythagorean theorem. Also for B prime. A squared plus B squared equals C squared. So this is being 9 squared plus 6 squared equals C squared. My students tend to like that better because it's a shortcut, but I'm going to go with what the book is doing, which is the distance formula, and really it's just the same darn thing, but visual people like it, in their own way. So 3 squared, I was going to put 9, make it easier on myself. And then plus 2 squared. So that would be, 13? All right. Over here, we've got 0 minus negative 9, 6 minus 0. Double negative 9 is 9 squared, plus 6 minus 0 is 6 squared, which is 36. Add 81 and 36 together, you get 117. So we get the square root of 117. Okay. So now we're going to divide those to get their scale factor. So we've got the square root of 13 for your original AB. Again, that's your pre-image. The square root of 117 for your image, AB primes. We're going to divide those to get your scale factor, which is the scale factor of 3. All right. Looks like we're done with that. Oh, that check. I love that they gave me horizontal lines. So look, here is my original figure because I do not have primes on the D, F, or E. So I'm going to count 1, 2, 3, 4, 5, 6. Okay. My new figure, my image is the one that has the primes, and it's 1, 2. And I am reducing. Reducing means that my number has to be in between 0 and 1. It has to be like a smaller type fraction. So I've got a 2. I've got a 6. I'm going to divide 2 divided by 6. And that simplifies to a 1/3, everybody. And again, you're going to want to simplify all of these to get a scale factor. So the scale factor is a 1/3. Oh, okay. I am done. All right. So if you have any questions, ask me or ask your teacher. Let me know what I can do for you guys. Scale factor is not hard, really. It's just a lot of multiplication and division. You just got to watch out if it's in a reduction or if it's an enlargement. So one thing they did not tell you in this lesson, which is something that they really should have said, is if it's an enlargement, your scale factor has to be bigger than 1. If they are congruent, your scale factor is a 1 because it's a 1-to-1 ratio. And then if it's a reduction, your scale factor has to be in between 0 and 1. So it has to be a fraction, decimal, or percentage that's in between 0 and 1 on your number line. If they didn't say that, they needed to really say that because, that actually kind of tells you what your K is going to look like. So keep that in mind. You guys let me know if you have any issues. Y'all have a great day.